During a training exercise, an Air Force pilot is flying his jet at a constant altitude of 1,200 meters. His task is to fire a missile at a target on the ground. At the moment he fires his missile, he is able to see the target at an angle of depression of 18.5 degrees. If his missile travels in a straight line, what distance will the missile cover? Correct to the nearest meter from the jet to the target. Right, so altitude of 1,200 meters. Altitude is a height, it's vertical. So we probably might draw that first. So we have an altitude of 1,200 meters. Okay, so then the angle of depression, so say we had the horizontal here, and you're thinking of imagine a plane flying along a horizontal trajectory. The angle of depression, this one here, and it's very clear, this is the angle of depression. So the amount you need to turn off the horizontal. If it's elevation, it's up. If it's depression, it's down. So this is 18.5 degrees, and I'm just going to I'm going to extend that line until we get to the horizontal. So that's horizontal, that's the ground. And we're just going to, this is the missile flight now. And then this is the target. We know that altitude is vertical. We're assuming that the ground is horizontal, so that makes a right angle there. Then we need, what we're trying to find is the distance that the missile covers. So it says it travels in a straight line. So it goes from the plane, so that's the jet's position there, all the way to the target along a straight line. So that is what we want, this x, or you can call it d for distance if you like. So what we need is an angle in the triangle. And if you think this is a horizontal line, and we know the ground is a horizontal line, so we have two parallel lines. And so with angles of depression and elevation, you will often use alternate angles are equal. So if I can see this 18.5 degrees here, and this angle here, they are alternate angles, so they are equal. So this is also 18.5 degrees. So once I've got all of that, I can use this triangle, I can label it up, find the right angle. Opposite the right angle is the hypotenuse. The angle that we're going to use is the 18.5, so opposite that is O. The other side is the A. Could think of that as being between the right angle and the angle that we're dealing with. So then decide which two sides are involved, so that's the O and the H, so that means sine, so it means sine angle. The angle is 18.5 equals O over H. So O is 1,200 over H is our X. So that must mean that X is going to be 1,200 over sine 18.5. Okay, so we've just multiplied through by X and we've divided through by sine 18.5. Go to your calculator. Remember, make sure you're in degree mode. I'll just have a quick look. So if I go there, I'm in degree mode. It's very likely for you in an IB exam, you'd be in radian mode, either because the examiner has reset it, or because most of the questions will be radian based anyway, the trigonometry questions. So I just need to do 1,200 over sine 18.5. Okay, so that gives me an answer of 3781.854. And we have been asked to the nearest meter. Always remember things like that. If you're not, one thing you could do is write right at the beginning of the question, just write sort of low down to the nearest meter, and then it'll prompt you to do it. Often that last step gets missed and you just lose a mark, and it should be the easiest mark. So to the nearest meter, this is going to be 3782. So 3782 meters. Remember, that's the distance that the missile needs to travel from the jet to the target. So it's the length of that line along there.